Today, we're going to talk about what I think are some of the most difficult word problems when it comes to quadratics, and that's dealing with revenue. So if we take a look at the first problem, it says a popular designer purse sells for $500 each, and 45,000 purses are currently sold each month. The company did some research and found that for each $20 decrease in price, they can sell 5,000 more purses each month. And this is kind of how sales work in the real world. So if you ever been to a store and something's on sale, they're gambling that, you know what, if we lower the price by this much, hopefully we'll get this many more people to buy it. So this is kind of introducing you to that word a little bit. And we'll keep it kind of general and keep it more simplistic than typical situations in the real world. So one of the things that I like to do first is take a look at these questions. It says, what is the max revenue? And if you remember correctly, the maximum means K. So you're actually trying to find K. In order to do that, we need to establish a quadratic formula. So we're going to have to write down some things we know. The first thing I like to write is a reminder that revenue is when you take the price of an object and multiply it by the number of objects sold. So that would be before you pay for costs, before you pay taxes or any of that stuff. This is just what you get from selling it, and then you would take things from that and pay your bills, whatever you have left over as profit. So we're just talking about revenue for right now. It's what you're bringing in initially from your sales. And right now, our current revenue model is $500 per purse, 45,000 purses per month. So we would multiply that, and that's the revenue that we're bringing in right now each month. So what we want to do is take a look at the difference between the current revenue and the model revenue. So I'll let you absorb that for a little bit because that's where a lot of kids get intimidated. Notice the 500 and the 45,000, that didn't change at all, right? We can't change where our model began. So those numbers are concrete. What happens is you're basically losing $20 per sale. So if 3 customers come into your store and walk out with a purse, you lost $60 that you would have initially had because of this $20 decrease in price. Well, the number of people coming into your store is going to change. I don't know if I'm going to have 3 people walk out with a purse or 10 people walk out with a purse. So it's just $20 every time. And that's why it says minus 20x, because the more people that walk out with a purse, the more money I'm losing from my initial revenue. In exchange for losing a little bit of money every time someone walks out, I get 5,000 more people walking in. So every time someone buys a purse, 5,000 more people come into my store and buy a purse. So there's a trade-off. Again, that number is going to fluctuate. So I can't just say 500 minus 20. That's if one person comes in and takes the discount. If more people come, it changes. So we have to leave that as a variable. This is the key to doing these problems. You have got to establish this model right here. If you notice, this is ready to FOIL. This is set up like our standard FOIL problems. And if you want to get K, you have to follow the process of FOILing, computing H, and then you can compute K. So you need this model in order to proceed in the problem. It's important to write what X represents. It's very, very easy to lose track of where you are in these problems. So it's really important that you remind yourself, X is the number of price changes that occur. Or you could say X is the number of people that receive this discount. However you need to word it, but this number fluctuates. I would also circle the 500 minus 20x formula, and I would label it as the price formula. That will help us in problem B. So I'm just being a little bit proactive here, but we want to remember this is the formula that tells me what I'm selling my purse for. So we got those steps down. Now we're going to go ahead and do the math part of it. If you want to label this as quantity, you can. There's really not a lot of follow-up questions about quantity, but that would be your quantity formula. So step one is we're going to FOIL it out. Now these numbers are very big, so I would exercise with caution. I don't think it's necessarily a bad idea to pick up that calculator and just verify that you're doing your arithmetic correctly. But if you do everything perfectly, this should be your standard form that you get from FOILing. So you do have some big numbers in there, and that's okay. This is, if you're dealing in the real world, hopefully you have big numbers to work with. Step two is we are going to go ahead and compute our H value. So we'll do opposite B over 2A. And a little trick that I like to do, I actually don't use a calculator for this. I actually like to just cross out a 0 for a 0, another 0 for another 0, and I keep doing that. I don't even need a calculator to do this. And I don't even think that hard about it. So I just cross out all the zeros. I really have 16 over 2. And that's fairly easy to do in my head. So I know H is 8. I recommend that you label it price changes. It's not $8, it's 8 changes in price. You're going to change it by $20 for a total of 8 times. Once you get your H, you can go ahead and get your K, and that's up to you. If you want to use this formula up here, you certainly can. Those are some really, really big numbers to type in the calculator, and if you mistype a 0, you'll probably get it wrong. So I recommend that you use this formula right here. They're both the same. If I FOIL this guy out, I get this guy over here, but this is a little bit easier and less frightening to work with. So I'll be using that formula. So I will put 8 in for where X goes, and then I compute them out. So 50 minus 160 and 45,000 plus 40,000. Going to multiply this together, and you'll find that your K value is $28,900,000. That is the max revenue that you can achieve if you choose to do the $20 off in exchange for the 5,000 more sales. That's the trade-off. That's the max revenue you get from that. So that is my answer for part A. Part B is actually going to be easier because all the work is done in this problem. It says, what should the new price of the purse be to guarantee that that max revenue is achieved? A lot of kids will write 8 because they think I'm asking for H. I'm actually not asking for H. I'm asking for the price when H is 8. And that's why I had you guys circle this price formula here. So I'll go ahead and pull that up. So instead of writing 500 minus 20x, I'm going to plug 8 in for x because that causes my maximum profit, or excuse me, a maximum revenue to accrue. 500 minus 160 gets me 340. So I want to charge $340 per purse in order to make that $28,900,000 happen. One thing I can tell you is when you do these problems, you want to exercise a little bit of common sense. So for example, if you write $8 here, I want you to think about what you're saying. We're talking about a $500 purse that all of a sudden we're going to sell for $8. Does that seem logical? I don't think you're going to walk into a Coach store and get a nice purse for $8. So you want to think about your answers and make sure they make logical sense before you go ahead and go with that. All right, so problem number 2 says we have a coat designing company. The average sales would include 400 jackets a month, and it looks like we're selling them for $60 each. We found out if we decrease the price or offer a $2 discount for every jacket, then we sell 20 more jackets. So the trade-off is I get a little less money per coat, but I also sell more coats. So hopefully that makes up for that. Letter A says, what price point do we need to maximize revenue? And B says, what is the max revenue? So no matter what you're doing with these problems, it's always a good idea to build a model, FOIL it out, compute H, compute K, because chances are you're going to need those letters in order to answer the question. So build your model, starting with price times quantity. The current price is 60 and the current quantity sold is 400. And then we're going to lose $2 per jacket. So we're going to lower the price $2 for X amount of times. But our quantity is going to go up $20 every time we lose money. So if you lost $2 4 times, then you sold 80 more jackets because you're selling 20 for every time you lost that money. So you built your model. What I'd like you to do at this point is pause the video and see if you can go ahead and FOIL it out and compute H and K. Once you have that information, then unpause the video and see if what you have matches with what I have. All right, so I know there's a lot of information on the screen right now, and that's okay. But check your work with mine. So we have to remember X is the number of times we change the price. If we FOIL it, we should end up getting negative 40x squared, 400x, and 24,000. Get that successfully, we can compute H, opposite B over 2A, and get 5. So we're going to change the price 5 times. So if you went ahead and got K out of that, I actually showed my work for K down here, since this technically letter B is asking for K. And we are going to basically, we were normally doing 60 minus 2H and 400 plus 20H. If we do that, we get K. And now I know H is 5. So I'm going to plug 5 in for H in each of these parentheses, and I get 50 and 500. That makes 25,000 as a max revenue. So if you can get your H and your K, you pretty much have got all the credit for the work in the problem. Now you just got to answer the questions. So obviously, since the max revenue is $25,000, letter B is done. Letter A says, what should I charge per coat so I get that $25,000 to happen? So we're going to just use our price formula, which is this guy right here, right? That's labeled as price. And we're going to put 5 in for X and get $50 a jacket. So if we sell our jackets at $50, we will max out at $25,000. So on your own, I want you to go ahead and give this one a shot since we did the last two kind of together. I want you to try this one solo, and then what I'll do is put up the answers and kind of just close that out. So go ahead and pause the video and give it a shot. Okay, so we have a fundraising company. They're selling cookie dough. Looks like they're actually going to increase their prices and try to gamble losing 5 less, or selling 5 less tubs of dough every time they do that. So you can go ahead and check if you're set up with mine. So here's showing the price increase, 50 cents per tub, but we're losing 5 tubs every time we do that. And then if you FOIL it out successfully, you should get the following standard form. If we do opposite B over 2A, we should get 8. And then if you want your K, you can just plug 8 into either your standard form or your other form, and you should come out with $5,760. For letter B, they're asking, so what do you charge per tub of dough? And again, we don't want to say $8. Normally it's $20 a tub. We're gonna not sell it for $8. I think that's too much of a discount. So we want to make sure we use our price formula. 20 plus 0.5 times 8, that's going to be $24. So we're going to raise it $24 per tub and hope that we make that $5,760 in revenue.